MTD CNC, bringing you the latest engineering news, reviews, events and special offers via video media.
Adrian, I met you in reception and you told me today you're going to revolutionise how people machine components. Can you talk to me about that?
Okay, so today we're going to be looking at two processes. We're looking at roughing and looking at finishing. So roughing typically is 30% of the cycle time and 70% is in the roughing, as in the finishing. What we're going to do with the finishing is use some new types of tool technology and geometry to give you cycle times up of 90% in savings.
Okay, and how's that going to be done?
By using barrel tools. There's this new type of barrel tool called a conical barrel. When used combined in 5-axis, you really can dramatically change the time taken to machine components.
Okay, is this software available currently?
Absolutely. This is part of the Hypermill portfolio. It's tool shapes in a variety of different cycles inside. We're using this technology now to, in certain cases, for lots of different customers.
Great, and as good as your software is, it's no good without cutting tools, so who are you partnering today?
Okay, so today we have a company called QuickGrind. QuickGrind are really doing a great job in supporting us in this today. These tools, as I said, are a new type of tool technology. You won't find them in a general tooling catalogues that you see around. So they've created tools specifically for us in this presentation today.
What sectors would this be applicable to?
I think that's the interesting part of this technology. It's not just for aerospace type components that you'll be seeing today. It's for all sorts, medical, mold and die, any part really which is got the right type of shape characteristic can be good for it. So it can also be good for blades, single blades, blisks, turbines. It has a wide portfolio of applications where it can be used.
Okay, and presumably we're going to be using tools, obviously. So how many tools will we see today?
Primarily we're going to be using probably 3 or 4 tools. This is the nice thing about this technology, but in particularly the barrel tool can be used in, it's one tool shape that can be used in a variety of different areas. So not just for finishing the walls, but also finishing the corners, finishing the base of the component. So your part count of tooling will dramatically go down.
And we're about to see a demo on this Mazak machine. What's the approximate saving when you look at the old method and the new method?
That's the really interesting thing. We would traditionally finish this pocket wall with a ball mill style tool. The pocket is so deep that you can't use like an end mill or cut on the side of the tool. You'd have to scan the walls. In which case, probably this pocket would take near 40 minutes to machine. Today you'll be seeing the barrel tools being used, and we cut the same walls in 4 minutes. So that's a 10 times saving in cycle time.
Wow, that's huge. Quite often when we see latest technology, new innovation, savings are 10, 15, maybe 20%, but we're talking about 90% today.
Oh, absolutely. This is really a big technology that we're pushing here today. We want to get out to the UK customers so they're able to be competitive and use this technology when they're competing.
That's a big claim and I can't wait to see it. Thank you. We're here at Mazak UK with Open Mind and yourselves at QuickGrind. What cutting tools are we going to see today?
Basically we're looking at high performance 16mm Mirage tools, taper barrel ball tools for doing the finishing, the high speed finishing strategies.
Okay, so barrel tools, they've been around, it seems like forever, but you don't see them, so there's a re-emergence, is there, of barrel tools?
Yeah, I think there is. I think it's a lot to do with the capability to drive the tools, where now the software is advanced that much. Now I think is the time for the barrel tools to re-emerge.
Okay, and what process, what application would you use a barrel tool?
Basically, it looks to me for high-speed finishing, 3D surfaces, anywhere where you traditionally would take very, very small step overs, say with a ball nose tool. We can now use these tools, obviously taking advantage of effective chip thinning and massive steps forward to give you much better finishes.
Great, I look forward to the demo.
This is the process of taking a large face mill and using the 5-axis process and running into component. So you can see here the tool is leaning forward, the part will spin, and it will go in the machine. So now we're going probably to about, we're spiraling down the part, I think it's about 3-4 mil step down. It will go down to probably 80% the total depth of the pocket. Then we'll again go to the 5-axis movement to go to the full depth of the pocket, and then continue with the spiral. Okay, so the depth of the pocket is now being reached. I think this is 155 millimeters deep. So now we're just cleaning the bottom of the pocket out, and then we're open the door, take a look, and then get on to the next step. Is hopefully you've seen the pocket has still quite a large radius in the corner. What we want to do now is take out as quickly as possible the rest machining in the corner. So the usual process with most applications is take the tool, spiral it off. So what we want to do here is we want to go the reverse, go into the pocket, go into undercut and pull it out, pull the tool out. And then as you pull it out, you're using chip thinning technique. Okay, because the tool's at an angle compared to the wall, as you're pulling it out, it's removing material very quickly. Okay? So you're taking a lot of meat out of the corners now. Now, this pocket is quite deep. If the pocket was more shallow, you can put a bigger angle on the tool, so they wouldn't be so noisy, you could be even more aggressive. So in this case, we're now going to use a simultaneous approach. Step down is 3.5 millimeters, using the barrel tool with a 500 millimeter radius on it. Okay, what you saw there was the finishing process, okay? And each pass it does is actually lifting up 0.3 or so, scooting across the top of the part and then coming in. So it's analysing whether it's quicker to jump to a new position or to ghost over the top of the part to a new position. So sometimes it's quicker to rapid or high feed rate. It depends on analysing which is quicker to do. Thank you for your time. Any questions? We're here.
For more videos, products and news, go to mtdcnc.com or follow MTD Online on Twitter.